Welcome, ladies and gentlemen, to Integrated Math 2. In today's episode, we will be discussing Chapter 11.2.3, which is Surface Area and Volume of a Sphere. And so we'll begin with 11-75, which begins with Alonzo learning about his geography class that 70% of the Earth's surface is covered in water. And he wants to understand how much percent of the Earth's surface is in the United States, how much area does the Earth's surface is covered in water, and what is the volume of the Earth. What are some things that he's going to need to know? Well, today's lesson builds around that idea. Ultimately, we're going to need to know how to find the surface area and volume of Earth. And so we'll probably need some radii in this case. We'll probably need some surface area and all that stuff. We will need radius and maybe even diameter. That way we can cut it in half to get radius. All right, so let's see how we're going to extrapolate the volume and surface area of our planet here. So we're going to bust out some geometry models. Now, ordinarily, you guys are supposed to bust out some plastic models of spheres and cones and cylinders, but for purposes of this, I'm going to have to kind of ask you to believe everything that I'm doing here. It says, in order to find his questions, Alonzo gets out some of his geometry models. He has a sphere, a cone, and a cylinder that all have the same radius and height. So in part A, it says, draw an example of each solid. So I'll go and just draw my cylinder here. Here's my cylinder. Here is my cone. And again, they all have the same radius and the same height. And it doesn't have to be perfect, but I'm going to try and draw them as best I can. Here is my sphere. Here is my sphere. All right, that's a pretty decent looking 3D model right there. Now, since they're all supposed to have the same radius and height, then we can conclude, switch over to pink right here, that each of them has a radius of r. Radius of r, and then radius of r. Now, which one of these is actually going to determine the height? Because we could just call each of these guys h. But actually, of the three, the sphere actually has the most information to give us what height actually is, because the radius will extend up and down in r direction, right? Because the radius is always around all in 3D. So actually, the height of each of these is equal to 2r. And so it says if the radius of the sphere is r, then what is the height of the cylinder? How do we know? That's how we know. So we can say then that the height of the cylinder, where'd it go? Right here. Okay, cool. The height of the cylinder is 2r because it takes 2 radii to construct the height of the sphere, and all 3 have equal heights. Cool. And now it says in part C, Alonzo's models are hollow and are designed to hold water. Alonzo pours water into the solids and compares the volumes. He discovers that when he pours the water from both the cone and the sphere into the cylinder, the water fills up the cylinder without going over. And determine the volume of the sphere if the radius of the sphere is r units, and we have to show all of our work. Okay, so this is the part where I kind of have to ask you guys to believe something that I'm doing here. And so basically, when we look at the volume of a cylinder, right? So the volume of a cylinder, right? We know that that's the area of the base. So area of the base times the height. Well, the area of the base on a cylinder and the cone, quite frankly, is going to be pi r squared. So that's going to be pi r squared for the circle. And the height is going to be 2r. So we know that if we was to simplify this, we would get 2 pi r cubed. Cool. So the volume of the cylinder is right there. Awesome. 2 pi r cubed. And so here comes the part that I need you guys to kind of believe me on here. It says the volume. So we know that the volume of the cone is equal to 1/3 times the volume, 1/3 times the cylinder, which is going to be 1/3 times 2 pi r cubed, which is going to be 2/3 pi r cubed. So that's the volume of the cone right here. And through the activity with these plastic figures and water, you're supposed to determine that the volume of the cube, not the cube, sorry, the sphere, it would take 2 of those cones. So 2 times those cones. So it would be 2/3 pi r cubed plus 2/3 pi r cubed, giving you a grand total of 4/3 pi r cubed. And again, that's the suspension of belief that I need you guys to kind of have, that if we had this activity in front of us, you guys would get 2 of those cones to fill the sphere. And of course, this relies on all 3 shapes being the same size, and of course they would be. So there is your volume of a sphere formula. So it's 4/3 pi r cubed. I'll be back with the next problem. Give me a second. In 11-77, it says, now that Alonso knows that the volume of spheres, cylinders, and cones with the same height and radius are related, he decides to examine the surface area of each one. As he paints the exterior of each solid, he notices that the lateral surface area of the cylinder and the surface area of a sphere take the exact amount of paint. And it says, what is the surface area of a sphere? So let's take a look at the surface area of a cylinder first. So the surface area of a cylinder is 2 pi r, right? 2 pi r squared, so that's going to be the circle up top and bottom, plus 2 pi r h. Now, it's important to know what each of these pieces is doing, right? Like this is the top and bottom circle. Top and bottom circle. This thing here, though, this is the lateral area. Lateral area. And what they're saying here is that this is equal to the sphere. So that means that the surface area of a sphere is going to be 2 pi r times height. Well, we know what the height of the sphere was. We talked about it a little while ago, that it's equal to 2r because it takes 2 radii to make the height. That's going to be 2 pi r times 2r, which is 4 pi r squared. And there is your surface area of a sphere formula. All right, I'll be right back with the answer to the Earth's volume and surface area bit. I'll be right back. All right, let's finalize Alonso's research here that talks about the area of the surface that is covered in water. So let's go ahead and find the surface area of the Earth. It does say that the radius is about 4,000 miles. So if we do surface area of Earth, that's going to be 4 pi r squared, which is going to be about 64,000,000 pi miles squared. Miles squared. And let's talk about the percent of Earth that lies in the United States. And so it looks like, so this number here, this 3 million some number here, we're going to use that. So this is the first bullet point. The second bullet point is, I'm sorry, what am I doing? We need to figure out how much of that is covered in water. So the surface area of water, I got a little ahead of myself there, that's going to be 0.7, right? So 70% of that is going to be 64,000,000. And so that's going to be, looks like about 448,000,000 miles squared is covered in water. Sorry about that. That is the first bullet point right there. Second bullet point is percent of Earth's surface that lies in the U.S. So what I'll do is I'll just do 3537438 over the 64 million that we found before. And that ends up being about 1.76% of the Earth's surface resides in the U.S. And then the volume of the entire Earth shouldn't be too hard. That'll be V equals 4/3 pi times 4,000 cubed. That's going to be a very, very large number. The calculator can't really handle it. You end up getting 8.53 times 10 to the 10th pi miles cubed. So there you have it. So area and volume of a sphere. And that will wrap up the surface area and volume chapter for Integrated 2. As always, please leave comments or questions in the comment area, and I will see you all in the next episode.